Alright, we're looking at homework 83. This is the homework that follows the introduction to vectors in chapter 3 here, two-dimensional motion. So first thing, number one, is just scalars and vectors. Remember, scalar quantities are quantities that have magnitude. Vectors are quantities that have magnitude and direction. So looking at number one, the acceleration of a plane. Acceleration has direction, so it's a vector. 2, the number of people. There's no direction on that. That's a scalar. Number 3, the time of the flight. The time is a scalar. Letter D, displacement of the flight. That's going to be a vector. Displacement has direction. And E, the amount of fuel. That's a scalar. Fuel doesn't have direction. So off to number 2. Number 2 can be rather troubling for some people, and that's understandable. You got a roller coaster. And the roller coaster travels 85 meters horizontally, and then it angles up at 30 degrees for 45 meters. So there's 45 meters, there's 30 degrees. We'll just leave the degree symbol off just because it's hard to do real quick. So that's 45 meters. That's our 30-degree angle right there. I'm going to kind of situate that right there for spaces. The end goal of this question is to figure out this blue vector that I'm drawing right here. Overall, what is the displacement of the roller coaster car? Now, given the information that we have, we don't want to work with this triangle here. We should always strive to create a right triangle. So always look for a convenient XY axis to work with. So, for example, I'm going to extend on my grid here an x-axis off into Nowheresville and extend a y-axis down right here. Now, if you use your eyes, you can kind of see, well, a large right triangle. And we always want to work in large right triangles. So just give me 1 second to copy this one. So if we reconstruct our triangle, and I recommend that you frequently reconstruct your triangles. You see this and this, and then if I draw another arrow here, if I draw it with a dashed line, we can see that in the second leg of the journey, the roller coaster went forward and up. So I have to assume that's right angle. With it being forward and up, now all of a sudden you have the height of the roller coaster, and you know how far sideways it went too. You can solve for that. If we just call these simply x and y, we can solve for those by using sine and cosine. So if I grab my 30 degrees, put my 30 degrees right here where it goes, put the 45 right there, using sine and cosine, we would solve it and we'd say 45 meters times the cosine of 30 degrees. That would give me the adjacent line here of x. Cosine is the adjacent over the hypotenuse, so that's why we can do this. So that's going to give me 39 meters right here. 39 meters right there. And then following the same logic over here, 45 sine of 30, and I get 22.5 meters right there. Well, now I can use Pythagorean theorem, take my 85 meters and my 39 meters, which represent the whole sideways motion here. So that's 124 meters. And my 22 meters vertically here, and that will allow me, just kind of move these guys out of the way, that'll allow me to figure out this triangle right here. So I'd use Pythagorean theorem again. A squared plus b squared equals c squared. And it comes out to 126. Next, in number 3, we got an airplane that is flying north at 250 kilometers per hour, and it's got a headwind blowing at it to the southeast at 75 kilometers per hour. Now, because they don't tell us the exact angle, we have to assume that it's exactly to the southeast, 45-degree angle. That's I'm just going to put the 75. I'm not going to put my units just so I can be fast here. And 250 there. Yes, the birds are chirping. So you got this going on here, and what we have to make a triangle out of it. We want this red vector I'm going to draw in right here as our final answer. Well, to get that, we have to take this one, and we have to break it down into an x and a y. By breaking it into an x and a y, we can then rearrange our vectors. Remember, our rules allow us to rearrange vectors. We take these vectors right here, and we can get rid of this one. Once we find those two, we don't worry about those anymore. Once we find them, we can rearrange them. We went north 250, south this much, and then we went east this much. And it's far easier to see how the triangle is formed. And to do that, we're going to use 45 degrees. 75 is our hypotenuse, and let's see, 75 times the cosine of 45 gives me 53 meters. So both of these vectors are 53 meters. 53 meters there and 53 meters there. They're both 53s. So if you subtract 250 minus the 53, and you get 197. So this is 197, the remainder of our axis here. So we got 197 here, 53 here, and then you use Pythagorean theorem, and you'd see that it comes out to be 204 meters along the hypotenuse. The big idea here is reorganizing our vectors so that we can make the triangle we need to. Remember, nose to tail, and then, of course, your hypotenuse doesn't exactly conform to that. Moving to number 4, it's the exact same process. The only thing you're changing is this 250 vector instead becomes 125, and just repeat. So you'd have 125 minus the 53. So that takes you down into the 70s, 72. And then you'd have that with the 53, and you do the a squared, b squared, c squared again, and you get 89 kilometers per hour that time. And then on number 5, the displacement is 0, because the water just kind of cycles back and forth and stays in the same place.